So today we're going to be looking at resultant velocities. Resultant velocity. So with resultant velocity, it's just simply the sum of all the velocities. You can see there is an illustration that I did here. You can see that assuming we have two velocities uh, that are acting in this direction, we have the v1 and then we have the v2. So you just need to determine the total horizontal velocity and the total vertical velocity. So you can see from what I drew here, you can see that for the vertical velocity, I added the vertical component of v1 to v2. You can see because they are acting in the same direction. If it was up, it would have been addition as well. So basically, the resultant velocity is a total velocity, sum of all the velocities you need to get for the vertical component and the horizontal component. Then you'll be able to determine your direction, the direction of the velocity. I'm sure most of you guys, you have an idea of what this is. Okay, let's look at an activity. There's one thing I always believe in. I believe in showing how to apply a concept to a problem. That is where the learning process actually takes place. Let's look at this simple question here. Now, the question says that a bird is flying due east. Where is east? It's flying towards this direction with an airspeed of 7 meters per second. You have to determine the resultant velocity if a headwind is blowing at 4 meters per second east. Where is east north? North, south, west, east. East 30-degree what? North. They said if a headwind is blowing at 4 meters per second from not 2, and you see it now. So we're going to draw this as from the bed is right here, is flowing due east. So you're going to write it in that direction. The velocity of the wind is what? 4 meters per second. East, 30-degree north, 30 degrees. Remember I told you that you are going to start with the cardinal point where the angle is referencing. Because this is what? This is north and this is what? East. They said east 30-degree north. So the 30 degrees is going to be that in that direction. So how do you determine your resultant velocity? How do you determine your resultant velocity? The resultant velocity is the total velocity. So the first thing we are going to do here is to determine sum of all the vertical and horizontal components. Okay, sum of all the vertical and what? Horizontal components. So the first thing we have to do here, this is 4 meters per second. So we have to resolve this into vertical and horizontal components. So we can just put a right angle triangle here. If you look at the direction of that, the vertical is going to be facing down, and then the horizontal is going to be that side. It simply means that it's going to be pointing down, and then the horizontal component is going to be pointing towards the western direction because it's coming from northeast. So we now need to solve this into vertical. The vertical component of this is going to be 4 sine what? 4 sine 30 degrees. So this is going to be the vertical component of the wind. And then the horizontal component, which is this here, is going to be 4 cos 30 degrees. Horizontal component of the wind. Okay, can someone give me this answer? Vertical component and horizontal component from the calculator. 4 sine 30. Sine 30 is 1/2. So 2 divided by 4 is 2. So this is what? 2 meters per second. Now, because the vertical component is pointing downwards, it's going to carry what? Negative. Can you give me what is 4 cos 30? 3 point what? 46. So now let's sum up the vertical and the horizontal component. Summation of the vertical component is going to give us what? So for the vertical component, we only have this value, which is what? Minus 2 meters per second, isn't it? For the horizontal component, it's going to give us what? For the horizontal component, um, it's going to be 7. The 7 is pointing towards this direction, the 7 meters per second. And then we have an arrow that is pointing towards the other direction. So it's going to be what? 7 minus 3.46 meters per second. So it's going to give us what? 3.5. So now we need to find the resultant. We need to find the resultant. How do we find the resultant? How do we find the resultant? This one is facing downwards, and then this one is, you can write it in that form. This horizontal component, 3.54 meters per second. This is 2 what? Meters per second. So the resultant is going to be, let me write it in this form. The resultant is going to be summation of horizontal component squared plus summation of vertical component squared. The horizontal component is what? 3.46 squared plus minus 2 what? Squared. So can someone give me the value of the resultant velocity? So that's the answer. Let's look at another question. This one is quite easy. Let's look at another question. Let me just give you some time to write. Give me just 1 minute just to write down the solution. Let's look at question 3. Can you guys try question 3? They said a boat, let me use this, is set to sail 70 kilometers per hour in a direction not 60 degrees west. That is northwest, right? So it means that it's supposed to go to going towards that direction, isn't it? Let me make this bold. Not 60 degrees. Your 60 degrees will be here. That one has been established. Okay. I said a wind of 30 kilometers per hour is blowing from a direction south. Let me look for that arrow again. South 20 degrees what? West. From not 60 degrees west. In not 60 degrees west, it means that it is northwest. Now, the other one that says that south 20 degrees west, it means it's southwest. It's going to southwest, but at an angle of 20 degrees. That's what it means. I know what you are saying, but I know it's more or less like a mix-up. It's going northwest, 60 degrees northwest. And I say that, remember I said that the angle is going to reference the first cardinal point, which is the north. That is why I put my 60 degrees there. It's going to reference what is north. If it was west 60 degree north, it was going to reference the western direction. So this is northwest. So the second one, they said a wind of 30 kilometers per hour is blowing from a direction south 20 degrees west. South. So that is southwest. It's referencing what? South 20 degrees. They said a current of 15 kilometers per hour is blowing from east So that is east north. That is east 30-degree north. So you're going to draw it like this. From you can see my arrow. Let me use another 30 degrees, right? It's going to be here. 15, this one is 15 kilometers per hour. 20 degrees, this one is 30 kilometers per hour. This one is 70 kilometers per hour. One thing about resultant velocity is that once your diagram is wrong, you're going to get the wrong answer. That is where the understanding comes from. So now let's try and get the component. Let me start from this side. So for 15, vertical component and the horizontal component. This is still 30, right? So this is the vertical component here. So with the vertical component, it's going to be sine, because I can see that it's going to be opposite, right? Opposite and what? Hypotenuse. So it's going to be sine. So it's going to be 15 sine what? Sine 30 degrees. Vertical component. Horizontal component is going to be 15 cos what? Cos 30. Let's come here to the one of 30 kilometers per hour. Or you can just do this like this, just to get your component. You can just draw it in this form. So with the vertical component there, this is adjacent because this is 90 degrees and this is an angle. So it's going to be, the vertical component is going to be 30 cos 20 degrees. Then the horizontal component is going to be 30 sine 20 degrees. Let's go to the last one here, which is 70. The arrow is going up, right? So let's try and determine the vertical and the horizontal components. Okay, this is 60. Can make this 60, right? So the vertical component is because this is adjacent. There is an angle here. This is adjacent, and this is hypotenuse. So because adjacent is there, this is going to be cosine. Let me write that somewhere else. It's going to be 70 cos what? Cos 60 degrees. That is for the vertical component. For the horizontal component, it's going to be 70 sine what? Sine 60 degrees. That's how it's going to look like. You understand what I'm doing? Yes, sir. Do you understand what I'm doing? It's different from yours. So now we just need to get the values, but I can write it in this form. Let's start with the vertical component. Summation of the vertical component. Now let's start with the one of 15. With the 15, it's coming from that direction. So it means that it's going to be minus what? Minus 15 sine what? Sine 30. Because with a vertical component, it's going to be facing down, and that arrow is going to be going towards that side. Okay, plus with a 70, the vertical component of 70 is going up, so it's going to be plus 70 cos 60. Then with the 30, 30 kilometers per hour plus the vertical component here is 30 cos 20 degrees. It's going up, right? So it's going to be 30 cos 20 degrees. Can you guys find me the total of these from your calculator? And I'll also confirm here from my side as well. With me here, I got 55.69 kilometers per hour. That's why I was asking you. That's why I was asking you that your 59, your 55.69, is it vertical or horizontal? And you see it there. It's supposed to be vertical. So this is the summation of the vertical components. I'm just going to give you some time to write, and then we'll look at the one for horizontal component, and then we'll calculate our resultants, and then we can confirm the answers from the textbook. Okay, let me calculate the horizontal component very quickly. Summation of the horizontal component. Now, with the horizontal component, let's start from 15. It's going towards that direction of west. You can see the arrow is going towards that direction. So it's going to be negative. It's going to be minus 15. It's minus 15 cos 30 plus with a 70. The 70 is also minus as well. Minus 70, 70 sine 60. Because if you look at that direction, the arrow is pointing up. The vertical will be going up, and then the horizontal will be pointing towards the negative direction. Then plus one of 30. The horizontal component is going to be positive because you can see the arrow is going to point towards that direction. So it's going to be positive. So it's going to be plus 30 sine 20. Can you help me to compute this? Okay, now the horizontal component, summation of horizontal components. The vertical component is 55.69. Let's leave out the units. So the resultant, can someone give me the answer? You can just confirm I got 84.35. Can we confirm if the answer is correct or wrong? It has to be correct. The 4.35. That's the answer. That is how to go about it. Who doesn't understand? You are being asked to determine the direction of the resultant velocity. So this one, I'm just going to take this one out. So with the direction, let me just use this. Can someone try to determine the direction? So that's going to be northwest, right? This is north and this is west. So let's just pick this angle here. Then we can construct a right angle triangle. So we can use that angle there. And if we're using that angle, of course, because this line and this line are parallel, according to the law of force analysis, is going to be 55.69. This line, distance from here to here. And then with the horizontal one, it still remains. And then we are going to use tan. It's going to be tan theta. The opposite is what? 55.69 divided by what? 63 point what? 35. And someone give me the value of the theta. When you divide it like this, or when you get the angle, the angle is what? You got 41.318. So if I want to write this now, it's going to be west 41.318 north. That is how I'm going to write the angle. You subtract that angle from 90 degrees, it's going to give you what? 48.68, right? So it means that this angle here, this one here is 48.682. So if you want to write this one, it's either you write your answer in this form or you write not 48.682 degree what? West. So either you write your answer in this form, I'm going to put it inside the red box, or you write your answer in this form. So this is correct, this is correct. It's just that one is not 48.682 west, the other one is west 41.318 north. So either of the two angles is correct. B part, right? The actual displacement is both in 90 minutes. This one is easy. Displacement, let me just write it here. Displacement is velocity multiplied by time. Now, because these values are in kilometers per hour. Okay, so what is 90 minutes in an hour? What to convert 90 minutes to hour is what? So 1 hour 30 minutes, 1.5. So you multiply that by the resultant velocity. Where is the resultant velocity? 84.35. You just multiply because velocity is distance over time. So the distance or the displacement is velocity times time. So the velocity you're going to use is the resultant velocity that you calculated there, multiplied by that time. If you want to leave it in minutes, you want to leave it in seconds or hours, up to you. That one is the easiest. So you just multiply the resultant velocity by the time. Understood? Okay, you can try to attempt this question. Any question online? Right. Thank you. The same process, you find your vertical, you find your horizontal, you use Pythagoras theorem to find the resultant. Then you find your direction. The same process. They said a ship sails 20 meters per second in the direction of east, 30 degrees, east 30 degrees north. Is this direction? East 30 degrees north. I said that because they wrote it as east 30 degrees north, so we're going to make reference to what? East, which is what? 30 degrees. 20 kilometers, 20 meters per second. Okay, 20 meters per second. It experiences a current of 10 meters per second flowing from the west. Where is this? 20 degrees what? North. So the arrow is going to be pointing down here. What's it from? Where's 20 degrees north? Okay, let me just leave it. the way it is. 20 degrees. So with this one, let me just indicate the direction of the arrow. This one is the direction of the arrow. You have to determine the magnitude and the direction of the resultant velocity. Let's quickly calculate the vertical and the horizontal component of each. Let me extend this one. For 20, let me just calculate that. This is still 30 degrees, right? And this arrow is pointing up. This arrow is pointing towards this direction. Okay, so the vertical component, I can see opposite there, and I can see hypotenuse there. So the vertical component is going to be equals to 20 sine 30 degrees. The horizontal component is going to be 20 cosine of 30 degrees. But one of 20 degrees, that velocity there is 10 meters per second. So let's determine our component. So the arrow, the vertical one is going to be pointing down. It's going to be pointing towards that direction. So the vertical component here is 20 degrees. Let me draw it on the other side. And this is going to look like this. This is 20. This will be what? This will be 20 degrees. You have your vertical component. So the arrow will be facing down, and then with the horizontal, it's going to be facing towards that direction. So with the vertical component here, is going to be sine. So this is going to be 10 sine of what? 20 degrees, the vertical component. The horizontal component is going to be equals to what? 10 cosine of 20 degrees. So let me just quickly calculate those components. Summation of the vertical component is going to be equals to, for 20, is facing up, it's going to be positive, it's going to be 20 sine of 30 degrees. The vertical component of this is facing down, it's going to be minus what? It's going to be minus 10 sine what? Sine 20 degrees. I want someone to determine that. The horizontal component, the arrow is facing towards that direction. It's going to be 20 cos 30 degrees. Then for the other one, is also facing towards the positive direction, which is the eastern direction, is going to be plus 10 what? 10 cos 20. 6.5, got 6.579, let's say 6.58 meters per second. Plus 10 cos 20. I got 26.717, 26.72 meters per second. Resultant velocity squared, I'm just gonna just do it the way it is, 26.72 squared plus, can someone give me the answer? The resultant velocity is what? It's going to be what? Can someone give me the answer? Can someone give me the answer? What is the resultant velocity? Just compute that. Compute that for me and give me the answer. Anyone online? You got 27, what? 518. So they got 27,516. So it's still correct. They got 27,516, 27,518, 27,517. They are all correct. Okay, so that's the resultant velocity. So the direction, we need to draw this component so that we'll be able to determine the direction, because they are both positive. So I can establish this is north, this is east. So it simply means that the resultant is going to be northeast because it's both positive and positive. Yes. So now that you've already established your vertical and horizontal component, so now from what I'm seeing here, from this figure here, this gave me positive, this gave me positive. I don't know the angle yet, but I know that the resultant velocity is going in the northeast direction because they are both positive. So the vertical component is 6 point what? 6.58. This is 26 point what? 72. So I can establish that is going towards this direction, but I don't know which angle. So I'm going to determine the angle now. So with the angle, I can use this angle here. Then if I'm using that angle here, I can close here. Now, the force is also 6.58 here. So I can use my tan. Let me write it somewhere. Let me create another slide because there is no space again. Okay. So I'm going to use this right angle triangle here. Let me just label it A. So I'm just going to draw it out. So at that vertical there, I have 6.58. I want to determine that angle, and I have 26 point what? 26.72. So I can use tan. So my tan is going to be tan of theta, 6.58, which is the opposite. The adjacent is what? 26.72. Can you give me the value of the angle? 13.83, right? So if I want to write this, it will be east. I'm going to write it as east because the angle is referencing the eastern direction. I'm going to write it as east, 13.83 degree what? Degree what? North. So if you subtract this from 90 degrees, you are going to get the other angle. This, let's subtract it from 90 degrees. You're going to get what? 13.83. So it's going to give us 76.17. So it's going to be north. You can see it's going to be referencing north. So you're going to write that one as north, right? 76.17 degrees what? East. That's the answer. Who got it? No one. Is it? Who got it? Who got it? Both. That's very good. Anyone online? Everybody is just quiet. I don't know why you guys are quiet. My class is not always quiet. It's always interactive. You think what I'm doing is wrong. Okay, so we're going to be stopping here. I think we are already 2 minutes ahead of the